Good morning, good afternoon, and good evening. Today, we have our participants from more than 23 countries in different geographic locations. We have participants from Japan, Australia, Europe, USA, Brazil, and India, and many more countries. I'm Smitha Rao, co-founder of Utthunga Technology. Thank you very much for all your time and presence. It's a privilege to have you all join today. We welcome all of you to the webinar, FDT Mobility Secures Open Automation for Industry 4.0. FDT as a device integration standard has a history of more than 2 decades now. With thousands of installations and more than 35 FDT-enabled host applications, FDT technology has supported 25 plus communication protocols. FDT 1.2, the earlier version of FDT, like any other standard in those days, was Microsoft dependent and supported only desktop applications. But with latest FDT standard 3.0, it is designed for open, scalable, secure, and interoperable architecture for the modern open automation for Industry 4.0. In today's webinar, we will share information related to FDT 3.0 standard and how it enables the mobility in the industrial workspace. I have Mr. Glenn Shoes, the Managing Director of FDT Group, as a guest presenter in today's meeting. It's an honor to have him as part of this webinar. Before we get started, I'll just take a couple of minutes to introduce our company, Utthunga Technologies. Utthunga actually means pinnacle in an Indian ancient language Sanskrit. We are a product engineering and industrial solutions company. We started in 2007 with a device integration as our core offering. We have more than 13 plus years of experience and partnered with the global industrial suppliers and host suppliers in their product development strategy and roadmap. We are a team of 500 plus professionals headquartered in Bangalore with a registered office in Europe, USA, and Japan. For quality assurance, we are ISO certified company and we follow CMMI level 3 standards. We offer services in the application development, embedded services, IoT, and verification and validation. Our services are targeted to OEMs and end industries in the process, factory, and power domains. Next slide, please. We have been associated with the Industrial Standard Organization as part of our journey. We have been associated with the FDT Group for more than a decade now, and we became the FDT Test and Certification Center in India. Apart from the FDT Group, we are also associated with the OPC Foundation, the OPAF the Open Process Automation Forum, Qualcomm Group, P&O, ODVA, and many more. We are also listed as a global experts in OPC Foundation and P&O organization. We are not just a member of these consortiums, we also participate and contribute to this specification. In this way, we help our customers to adopt these standards and specifications as part of their product strategic roadmap. Next slide, please. I would like to introduce our speakers today. I'm co-founder of Utthunga Technology. I'm also device integration and OPC expert. I was FDT OPC working group, which was formed in collaboration with OPC Foundation and FDT Group. I have presented various white papers and IIoT publications related to these standards. I have 17 years of experience in this industry and part of various working groups in multiple consortiums. It's an honor to have Mr. Glenn Shoes, the Managing Director of FDT Group, as part of today's webinar. Taking over the Managing Director position in FDT Group, Mr. Shoes was an executive at Rockwell Automation with the responsibilities that included the process industry asset management businesses. He has numerous design credits, articles, and patents in the area of real-time information-based material and industrial and process control security and asset management. Next slide. Yeah. With this, I would like to hand over this to our guest speaker, Mr. Glenn Shoes.
Thank you very much, Smitha, and it's a pleasure to be part of your seminar today, and welcome to our global participants. I hope you're all healthy and things are gradually improving in your various geographies. Our agenda for today is in front of you, but before we get into that, I'd like to just mention that this session is being recorded, and after the seminar, we will offer a link to all the participants for the recording. Questions will be taken throughout the seminar. You may go to the chat feature on your control panel and ask any question you'd like. We will hold all questions till the end of the presentation, at which time Smith and I will do our best to address all those. We've got Katie in the background monitoring that chat feature, so if you have any other technical questions or general seminar issues, feel free to chat with Katie on those topics meanwhile as well. So on to our agenda. So I'd like to just cover a little bit about the state of the industry as we see it from an FDT perspective, and then cover our new automation standard, the FDT3, and how it's open and secure by default. We'll talk specifically, and the bulk of the conversation will be about the FDT3 mobility capabilities, how we mobilize the industrial workforce through that capability. And towards the end, we'll wrap up with how do you develop an FDT3 mobile solution using our new standard and our new tools. And then we'll leave plenty of time for questions and answers. So a little on the state of the industry from an FDT perspective. We took time in our new standard, as Smitha mentioned, we've got now more than 20 years of experience in this type of standardization activity around the world. So we took time to acknowledge that this is becoming a more diverse solution as time moves on. Clearly, if you look at the beginnings of the FDT group, it had its foundation in the process automation industry. We since in the following decade have spent a great deal of effort in making the standard capable and supporting the full factory automation industry. And in between there, of course, we also cover hybrid automation like breweries and other integrated type facilities. But our basic hallmarks as we do this are we do open integration. So we're an open standard. It is a written standard and it's accepted around the world by all the various standards bodies. What you'll see in the FDT3 standard in specific, and we really started this transition back with FDT2, is we're a very data-centric standard so that you can look at the FDT standard in order to get live data from your facility. We've since have added capabilities for mobile, and of course that's what we're here to talk about today, and a close parallel to that is being able to remotely access it. But what we're clearly seeing with all the various market drivers such as Industry 4.0 and others is that the architecture to do this has to be very flexible. And that starts with scalability because the solution as we see it has to span anywhere from a simple skid-based application up to supporting a multiple facility enterprise application in the cloud. It has to be very agile. And as many people take a close look at the standard, they want to know that with the mobility and remote access that we've taken the care to make it extremely secure and robust from that perspective. And that we retain compatibility, not only with all the different networks that Smitha mentioned, but also with our legacy, so that prior products, prior standards through the FDT standard are compatible going forward. And we'll talk about that. So the FDT3 standard, we actually, from a security perspective, started with the notion of a secure standard. In order to do this, our normal development process would be when we're looking at adding features to the standard or revving the standard, we have a working group inside the FDT organization that's called Architecture and Standardization, and they will take the requirements and convert it into technical documents that eventually become our standard once our membership votes on it. In this case, however, we took a parallel track with security. So we created a separate security working group whose only duties in the context of developing the FDT3 standard were to look at it from a security perspective. So lay out the architecture around security, how should it be designed, and then ensure that as ANS writes the technical part of the standard, that it complies with those security guidelines. And they've also been an excellent reference to ANS as they've developed the standard, as obviously they have to work closely hand in hand. So both of these committees are comprised of industry experts from various leading companies around the world. And of course, it's standardized. That's the very notion of what the FDT group does. Any one company could set off to do these kind of things, but then they end up to be a fairly limited scope solution and really don't help with the ability to integrate devices and capabilities from a wide variety of vendors in the industry. So we're pretty well focused on the standardization activity. One totally new feature in the FDT3 standard is that we are now platform independent. So the standard can run on any major operating system and you can access it using any other major operating system. It is interoperable, not only across all the different networks, but across all the different vendors. And as we'll cover here in a little bit, also with previous versions of the FDT standard. Some new capabilities within the FDT3 standard include a web interface. So in the past, if you've interacted with the FDT standard, you may be more familiar with doing it in a single user desktop environment, although there are client server versions of it available in larger asset management systems. But I think it's fair to say most people experience FDT in a desktop environment. That's now changed. While you can still enjoy that desktop environment, if that's your application space, you can now access all the FDT capabilities through a standard web browser. And with FDT2, we had added OPC UA capability in close collaboration with the OPC Foundation, and we continue that forward with enhancements, and we'll talk about those in the FDT3 standard. One of the other key architectural decisions, particularly with FDT3, is to make it a very information-driven architecture to supply the needs of the industry. Integration with things like higher level systems, asset management systems, production management systems, even up to an SAP level, to be able to get that information live off the factory floor without having to disturb the PLC or DCS environment to get access to that information. And it's a service-oriented architecture. We've got both web services available in the architecture as well as the OPC UA capabilities that make it a very flexible model to be able to acquire information from across the enterprise. So if you haven't seen it before, this is the basic architecture for our FDT3 application, or FITS as it's called. And in the center of the diagram, you're looking at the FDT server, and we'll be focusing a lot of the conversation around that FDT server and what's inside of it. But you can see surrounding that, there's a fairly large ecosystem, and we'll get into some of those details as we move along here in the seminar. So first of all, it's a FDT IIoT platform is the way we express it, because it was designed to meet the needs of the IoT type capabilities. So it's a single server environment that can handle an entire enterprise, a single facility, or a small skid. It does support skid to cloud based solutions, so it scales from end to end. And as I mentioned, we have the built-in security within the model so that as you spread out this application further across the enterprise, you can be assured that the security is robust. And you can see that in the diagram, wherever there's an ingress or egress to the server, those are secured connections using industry standards. We have the platform independence. We recognize that as people move these types of applications to the cloud and other edge type applications, that it isn't always going to be a Microsoft platform. So you can take the FDT server and run it equally well on a Linux or Apple operating system. Included in every FDT server is a native OPC UA server. It's inherently embedded in the server. So when you see that FDT server, you can take comfort in the fact that all of the data from the factory floor can be served up through that FDT OPC UA server that's built in it. We also have the embedded web server that's automatically a part of any FDT server. This is how you access both the information and the graphical user interface of the FDT installation. So where in the past you might have looked on a desktop to configure a device or troubleshoot a device or configure a network or look at network loading, those types of things, you can now do that remotely through that embedded web server. And of course, we maintain our universal device integration capability. We can support any network in the industry, whether it's a legacy network, a proprietary network, or a well-accepted industry standard network. The topology and the standard itself directly supports that, and we can support any type of device on those networks. And to help support our developer community, and we'll talk about this in a little bit more detail towards the end of the seminar, we have developers tools available both to develop the FDT server as well as the FDT DTMs, which are essentially the device drivers for the individual devices that connect to the server. We have those and call them common components, which are developers toolkits, so that the majority of the work is done for the developer and they only need to integrate their specific capabilities. So let's talk a little bit about security in the automation environment with FDT. So we have a distinct integration advantage. Sorry, I've got just a minor technical issue here. Let me resolve it. There we go. So we have the FDT IIoT ecosystem around the FDT standard. So we have the FDT server, and you can look at that as the central point of the architecture. So it supports distributed architectures. This could be for a single facility, or it could just as well be multiple facilities. You can, if you would prefer, you can implement the FDT standard as a desktop application as you have in the past. So this supports single user type architectures and yet offers OPC UA capability through that single user interface. And then the other part of the equation is the FDT DTMs. So these are essentially the device drivers that the device manufacturer writes in accordance with the standard that describes their device, interacts with their device. It has wizards in it so that they can help you through the configuration or troubleshooting the device. It usually has the manual associated with the device, and other things are all built into that DTM that's supplied by the device manufacturer. From a deployment perspective, we've got this skid to cloud scalability that I had mentioned. We can also do this in a number of ways in terms of where the physical server is. So certainly a cloud type application is very realistic, and that of course gives the advantage of scalability and performance and redundant installations on an on-demand basis. But you could just as well take an FDT server and locate it on-premise. So for example, if you were supporting a single facility or maybe a single line or a single process, you'd have an on-premise server perhaps, or as we're seeing more and more applications move to the edge of the facility, the architecture also supports edge-based applications for the facility or for the enterprise. I'll stress again our cross-platform functionality. We took a fair amount of time to make sure that any FDT server and any FDT DTM can run on any major operating system, as I've described, and as well as the browser application can be on any operating system, so you can have this cross-platform functionality when you go to deploy. One of the nice things of the new standard is that you can get direct access to data, so you have direct access to maintenance information and optimization data. And we'll talk about that from an application perspective. Smith will get into that in just a little bit. We can support all the IT and OT type protocols. So typically the server, for example, would be sitting on a typical IT Ethernet backbone of some type, and yet it can directly communicate with all the typical factory automation and process automation protocols. In fact, in the end user won't even be aware of what network a particular device is on. They simply see the device and can communicate with it, even though the FDT server itself may have to tunnel through many layers of network to talk to that device. That's all handled transparently by the standard. And we do maintain backwards compatibility. We recognize there's been millions and millions of prior generations of DTM shipped. And as Smith mentioned, there's many install base of from a desktop perspective in many applications. And so backwards compatibility is an important hallmark for us. And in the FDT desktop environment, you can freely mix prior generations of DTMs into an FDT3 desktop environment. So that allows you to maintain exactly the same topology that you have today, but to be able to start to take advantage of the FDT3 capabilities until such a time you're ready to go to a purely FDT3 environment with the FDT3 server. Of course, you could just as well, if the FDT desktop application serves all of your needs, there's no reason then to change that architecture. You can move forward in that configuration. And the topic that we're often asked about is the FDI device package. As you may be aware, the FDT Group is a co-owner of the FDI specification. And we do, on the desktop environment in particular, have the ability to integrate the FDI device package into that same environment. So not only can you mix prior versions of DTMs, you can also bring in FDI device packages as part of the mix. And that's due to special DTMs offered by some of our members that will directly process that device package and present it within the FDT environment. So you get basically a universal platform regardless of what configuration methodology you have. All right, just focusing specifically on the web server. So I mentioned we have the integrated web server. That's a standard feature of the FDT server. In fact, all of the visualization that would occur relative to that FDT server is handled strictly through the web server. So you can use any major browser to access that server just as you had in the past on a desktop environment, except now it's browser-based. This completely modernizes field device management because it offers a much greater flexibility in the environment that it's deployed, and as well as flexibility in your changing business environments. One of the hallmarks of this is that it transforms this ability to access the information from the factory network environment to be able to do remote asset management. You're no longer physically tied to a particular desktop or location to be able to carry out your activities. The embedded OPC UA server, this is a standard OPC UA client based server, so you can connect to it with any OPC UA client as long as you have the right credentials and security privileges. And you can browse the topology just like you would on any OPC UA server to see all the devices that are connected to the FDT server. and then to expose all the information related to those devices. So this enables true IT OT integration of this real-time data, because you could just as well take that OPC client and have it in an app in a business environment. For example, a dashboard to monitor performance metrics would be easily done with the integrated OPC UA server. And we also support through that the ERP and MES type connectivity. You have probably seen, or maybe you have hands-on experience with the fact that the major MES manufacturers are including OPC UA capabilities in their applications. And so those two can connect directly to the FDT server to get access to real-time data. And of course, we support the OPC UA pub sub environment that you're starting to see more and more about. We have end-to-end security in the model. So, it would be perhaps tempting by some to, when you're working on a security model for an architecture, to come up with some new security standard, but we recognize that there are some very well vetted, very well accepted security standards out there in the industry that are accepted both by the IT side of the organization and the OT side of the organization together. And the number one open standard for that is what's called TLS. This allows authentication of devices, of people, of servers, as well as encrypting the communications that get established through that. It's handled through the use of 509 V3 certificates for authentication, and thereafter it negotiates an encryption protocol that's acceptable to the organization, and all communications after that are fully encrypted. In addition to that, we retain what we've always had in the FDT standard, and that's role-based security. So once you make it through the TLS level of authentication and encryption, you then still need to log in with your individual credentials, the typical username and password, and that establishes your role in the organization and what rights and privileges you get through the FDT server. The way we position the FDT server in the architecture, it closely parallels, if you follow the NUMAR organization's any 175 architecture, it closely follows what they're trying to do with their new architecture. So it provides essentially what NUMAR calls a second channel for automation information. It provides that because the FDT server sits at a peer level with the PLC and DCS. We're not reliant on those in order to get access to the factory floor information or network type information. It is open and secure, of course, as NUMAR has asked that capability be within any 175, and you can get access to a wealth of things and carry out a variety of functions such as device health management, maintenance activities, asset management, and so on. And because this is not dependent on the PLC or DCS, when a new need comes up to access some piece of information within the factory environment, you don't have to get in and do some modifications in the PLC or DCS to get that information. The FDT server has direct access to those devices, can directly secure the information that you're looking for, and pass it back to you through OPC UA or web services. So with that, I'd like to turn it back to Smitha, who's going to talk to you a little bit about some of the mobility capabilities within the FDT standard.
Thank you, Glenn. You can go to the next slide. So with the FDT Mobility, we can improve the service efficiency. It also reduces the maintenance cost. So maybe we can discuss in detail on this in the next slide related to the mobilizing the industrial workspace. So mobility has been the main area where industrial automation ecosystem has been evolving. There is always a need to increase the equipment uptime and extend the asset life and this can be achieved using FDT mobility, and we are going to talk in detail on this in the next few slides. Next. So in case of earlier, it was always that device, whenever we used this industrial standard, we actually represented this device as an object. So for each devices, for example, in case of even the earlier version of FDT, for the device, we had something called DTM, that is device type manager. But with FDT mobility and with FDT 3.0 architecture, now it is not device equals to object, but device can be represented as an applications. I'll be talking about some of the case studies about this in the next few slides. Next. So as you can see that these are the DTM interfaces that is being exposed via web server. So we have a device parameters, all the FDT functionalities that is there in the earlier version of FDT, which was a monolithic application, can be exposed as a web interfaces using the FDT 3.0 device DTM. So it has a web interfaces to expose the device identification information, NUMAR NE10 device status. When we say device identification information, it includes both hardware identification and also the serial number, apart from manufacturer code and the device type code. You can also expose the manuals, technical documentation, certificates as part of this DTM via web interfaces so that you can access it remotely. You can have the complete user interfaces available using this web user interfaces. So with this FDT, which was earlier a kind of a desktop enabled applications, has become a completely supported the distributed architecture with the WebUI in place. So we will be showing some of the case studies about this in the next few slides, which was done by Flowserve, and I'll talk about this in the next slide. Next. So apart from this FDT mobility, also there is a common component which is licensed by FDT Group, which we can use it to develop the application for FDT technologies. So this common component, which is from the FDT Group, has support for not only Windows but also other platforms including Android, Linux, and iOS applications. Next. So if you look at when I spoke about web user interfaces, the message between the web UI and the business logic in case of web user interfaces is using the JSON format, and it is being completely secured using the TLS security. Next. As you can see here, FDT 3.0 style guide has a support for responsive web user interfaces. As you can see here, there is a definite place which was defined by the FDT standard for this device identification information, navigation information, device health status, and also work area. So in this way, what happens is, even the devices that different types of devices, it could be an actuator, it could be a flow sensor devices, or it could be temperature devices, and from different vendors, but all of them should look same. So that is how the FDT style guide helps it, so that when you go for a certification of your DTM, then it will be validated against the FDT style guide to ensure that it is interoperable. And with respect to FDT 3.0, it also supports the responsive web design. Next. So it is not just limited to the desktop environment. It also has a flexibility to adapt itself to the different aspect ratio of the display area. It could be a mobile platform or it could be a tablet platform. So FDT 3.0 takes care of these minute details as part of their standard so that end user can feel that harmonized user interface is being seen irrespective of the communication protocol, the device supplier, or the different device types. Next. So this is how you can see the same user interface in a different display areas, whether it is a tablet, is a laptop, is a desktop, or is a mobile platform. So there is a beautiful case study that is being done by Flowserve along with the help of other FDT group member, and we will be showing that case study. We will be talking more about that in our next few slides. Next. So as you can see, the FDT server provides the data to a different. It opens up the data not only to the FDT client. Earlier, both FDT server and FDT client was in the same network and also in the same systems. But now with the FDT 3.0, it enabled the service-oriented architecture. This means that the data that FDT server possesses regarding the information that it acquires from the device can be exposed to the FDT client application via web interfaces. It can be exposed to the OPC UA client via OPC interfaces. And since in the mobile also you can develop a mobile application either using a mobile enabled OPC client or web enabled FDT client. And there is also, since it is a FDT supports OPC UA technology, it supports both client server and pub/sub mechanism. We as Utthunga, we have done a prototype and research and submitted a position paper on asset health monitoring using OPC pub/sub mechanism and how it actually reduces the network traffic and helps in IoT adoption. I'll be talking about in the next few slides. Next. So if you look at that entire FDT 3.0 scenario, you can develop the customized app leveraging the FDT 3.0 ecosystems. So the data that is being acquired by FDT server, which also includes the business logic information, can be exposed to the app, and you can develop a simple or a complex applications. And this enables a new ecosystem altogether. Some of the application that we can see is a customized view for the production data. It could be modern asset management practices, remote monitoring of the informations, or it could be a diagnostics and service tool app. You can develop an applications based on the device data that you acquire. You log the data and run the predictive maintenance on this data based on the data analytics. Next. So in the next few slides, I'll be talking about some of the case studies related to the mobilizing the industrial workforce using the FDT 3.0 standard. Next. So as you can see, Glenn has already mentioned about these things, like he has beautifully explained about FDT 3.0 architecture. As you can see here, FDT mobility, when we say FDT mobility, it can be achieved via two different ways. One is using FDT OPC UA server, as you can see here. Another one is using a web server. So FDT server remains the same, but it can expose the information in two different ways. FDT core server, when it exposes this information, it exposes via OPC UA interfaces. In the next slide, we will be differentiating between the OPC UA server and the web server. Next. So since FDT mobility can be achieved by either OPC interface or via web interface, but what is the difference between these two and what you can expect from these two interfaces being explained in this slide. As Glenn mentioned, FDT OPC UA information model is a joint collaboration work between FDT Group and OPC Foundation. And the first version of this been released somewhere in 2017. And this standard is built on top of OPC UA for Devices Companion Specification Standard, which is part 100. I was glad to be part of this working group and contributing to this specification. As you can see, the FDT OPC UA information model, where there is a mapping between FDT interfaces and OPC UA address space. With FDT OPC UA information model, we can expose device identification information and the entire topology of the network. For example, if the FDT server is connected to Profinet gateway, which is connected to the hard device, then it is possible to see this entire network topology as part of FDT OPC UA information model. Hence, on the other end, using OPC UA client, you can access this information. We can also perform offline and online configuration. It is not just monitoring the data. It is also possible that we can configure this device using the remote OPC UA interfaces. We can monitor the process values, fetch the documentation, which could be user manual, wiring diagram, etc. There is also an important concept that was brought in FDT interface known as static function. The main reason behind introducing this static function concept in FDT interface is usually whenever operator wants to read the device status values from multiple devices, maybe 100 devices connected to the network. Before FDT 2.0, it was required to instantiate the entire DTM to access this single interface of device health status. So this actually consumed a lot of resources and performance was hit in this scenario. So in order to resolve this, FDT 2.0 onwards, the concept of static function came into picture. What static function allows is, it allows you to access the device status values or the process values without instantiating the entire DTM itself. In this way, it is as if you are just calling this API on a small software, which is you need not be instantiated. There are some standard static functions which are exposed via FDT interfaces, which includes get device status and get process values. And apart from this, via OPC UA information model, we can also expose non-user interface methods, like the methods which does not require user interfaces. Just to give an example, reset the device configuration counter, which actually executes a small function inside your device and reset the device configuration counter, which does not require any user interface. These kind of a simple methods which does not require UI can be supported by FDT OPC UA information model. OPC UA is the interface between FDT OPC UA server and its client application. So OPC by itself brings the security in principle. So the security features of OPC UA, that is certificate exchange, user credential information, or even the signing of the messages that is allowed in OPC, the benefit of this is also brought into this. And another point is FDT OPC UA server, this is applicable from FDT 2.0 specification itself onwards. So you can have this facility from FDT 2.0 specification itself. Since it's a OPC enabled, it can be extended to support OPC PubSub mechanism. With FDT 3.0 web server, it is much more than what is offered via OPC UA server, because the entire device functionality can be exposed via web server here. Apart from that is being listed by the FDT OPC UA server, FDT 3.0 web server allows the common DTM functionality like compare, static functions, non-standard function, and even if you have a complex GUI methods that can be supported via web server. And this, it allows you to entirely recreate the web client remotely using this web server concept. And this web server concept is supported from FDT 3.0 onwards. Next. As you can see here, with FDT 3.0, it changed the ecosystem itself. Earlier, we had a FDT host supplier and a DTM supplier. But with FDT 3.0, we have a app supplier. So if with with FDT 3.0, you can develop a simple app. It is similar to how you have in your mobile phone. You can download the app from the App Store. Similar concept can be utilized using this FDT 3.0. Next. So I'll be talking about these specific use cases in my next few slides. Remote monitoring and diagnostics tool, asset health monitoring applications, device connection assistance app, and how does it actually work. Next. This is the case study that is run by Flowserve company to demonstrate FDT 3.0 capabilities. In this example, you can see the prototype development. It uses both OPC server and Flowserve web portal. In this example, you can see that FDT Server 3.0 server is actually displaying 10 devices connected in the plant of Flowserve in USA. For these 10 devices, we can see the summary of asset dashboard listing the number of devices with a NUMAR health status information. For each of these devices, you can get more information like real-time information, process values, and many more. It also displays the device health status information related to the specific device categories, like whether it is a valve or a positioner or actuator or control. So in this way, the entire FDT 3.0 is not just the theory, it is also being validated with this specific case study. Next. So when you find this specific information, you can also NUMAR health status information. You can also go a little deeper into this. It is not just saying the device is not working, but you can also see the information related to the device, the reason for it, and also the how you can provide the remedies for it. And this category is not only for remote monitoring, but also it has supported device commissioning and calibration and device diagnostic information via FDT Server. So you can get the video of this specific case study from the FDT Group website. I encourage all of you to visit FDT Group website to see this entire demo of what I'm presenting now. Next. This is one of the case study that was done by Utthunga. So we presented this case position paper in one of the SICE event, and it is also we are applying it for IEEE publications. In this, what we had done is we had taken the FDT server, OPC UA server, and on top of that, we have included the OPC PubSub module. So when we have a OPC PubSub module, what it brings is the information that is captured by FDT server, you can push it to the middleware broker, and it can be accessed by n number of subscribers. As you know, with the client-server architecture, it is required for the client and the server to maintain the sessions. So when we have to maintain the session, it consumes resources. So when you have to scale this application, then you will have a problem with managing each sessions and connections and handling this data. With the OPC PubSub mechanism, you will not know the subscriber will not be aware of the publishers will not be aware of the subscriber. So as a publisher, for example, you can just push the informations to the middleware broker, which we call it as a topic, and that can be consumed by any number of subscribers, which could be a valve diagnostic application, which could be asset health monitoring applications, and which could be KPI dashboard. Since you don't have to maintain the session between the client and server, it reduces the traffic between the data source, which is nothing but the device, to the data consumer, which is nothing but the applications. And also, since it is a pull mechanism, you don't need to keep asking for the information, give me this data, give me this data. Instead of that, the data is available only when there is a change in the data. So this has been achieved via using OPC PubSub mechanism. Next. So we have extrapolated the same use cases for the Asset Health Assistance app. So as I mentioned earlier, I said that there is a possibility of creating an app. So you can say, for example, maintenance engineer with the tablet and with the FDT 3.0 Asset Health Assistance app, he can walk the shop floor and ask for a list of the devices near him which needs the maintenance. So behind the scene, FDT 3.0 mobile app finds the nearby devices, and then it's requests the FDT server for the information, and that will be displayed. So you can create this small utility functions using FDT 3.0 mobile app. Next. So similarly, like this is a very simple use cases. For example, now operator is finding it hard to connect to the devices. Like he doesn't know how to find the terminals, or he's not able to find how to do the wiring. So in this case, what he can do is he can actually scan for the devices and ask for the FDT server for the user manual. Technically, you can do it by browsing the Google or browsing the web, these things. But the thing is, the versioning of this data or the accurate information is possible because the device supplier knows for this specific devices, this is the device manual that is associated with this. The reason for bringing this simple app as part of this webinar is, here we wanted to convey the message that FDT 3.0 application need not be very huge application. It not be very configuration and diagnostics tool kind of application, or a very functional rich applications. It can be as simple as this one. We can definitely expand it to the later things, but yeah. Next. This is another use cases that we would like to bring in. Remote monitoring of the KPI parameters. For example, there is a chemical fertilizer plant, and you as an operator, he just wants to see the overall flow or inventory of this information. And using FDT server remotely, he'll be able to access this information. And if he needs only this information, we can create a simple app just to get this information. And in this way, you are bypassing the entire DCS and other ways. Next. Yeah. Now I'll hand over to Glenn to continue the.
Okay, thank you, Smitha. Appreciate it. I'd like to just spend a couple of slides just talking about, we've heard a lot now about the applications and the architecture and so on related to mobility, but just spend a few minutes talking about how you develop an FDT3 mobile solution, and then we'll open it up. I see we have a number of questions asked already, and we'll try to get to as many of those as we can in our remaining time. So from a general perspective, we have what we call FDT common components, which are our developer tools for those that wish to create FDT-enabled solutions. And it handles the entire ecosystem that Smith already pointed out to you. The tools will develop solutions that are platform independent. So you can develop it and deploy it in Microsoft in one instance, and without changing anything, you can run it on a Linux platform, for example. And the common components are really out of the box ready. So the FDT server, in fact, is so complete that you could just compile it and deploy it as is if you don't want to add any other features to it. Many vendors will integrate it with other capabilities and add value-added differentiation to it, but it is complete as it stands. Similarly, the FDT desktop common components could just be compiled and used directly as is. The FDT DTM common component developer tools are complete, and in fact, it includes a sample DTM in it so that you can see how to construct a DTM using the tool. As we've mentioned before, when you integrate this in your product solutions, you are automatically OPC UA enabled. If you're creating a DTM, you don't need to do anything else to make that DTM work with OPC UA. It's automatically built into the standard, and so it's directly handled for you. You don't have any OPC UA learning curve or anything related to that. Similarly, the server has the OPC UA server built into it, and that's fully integrated as well, so there's no learning curve there in order to deploy OPC UA solutions. The development environment is very modernized, so your web activities, instead of being Microsoft-centric, are the much more popular HTML5 JavaScript environment for all of the user interface activity. There's plenty of opportunity to do value add to competitively differentiate your products in offerings. In fact, the tool set is specifically built so that you can focus on that activity and not so much on the standard. And you can also develop apps, as Smitha mentioned, that can connect to the FDT server. This is what it looks like from a DTM development perspective. The common components you see in the upper left are the starting point for developing a DTM. There's a couple of different types of DTMs you could potentially develop. You can make a device DTM, an interpreter type of DTM. You can also make communications DTMs that enable various gateways or protocols. Those are all possible, and you can see those are all developed through the same common component tool set, and when they're developed, they'll work on any of the operating systems that we've talked about before. But what they have in common is as you come to the end of the development, they go through a tool and a process that starts with the DTM inspector that's pictured there, and this ensures compatibility with the standard. That test is rerun at an independent authorized test laboratory. And once you have passed the test criteria, you can then issue your DTM to the marketplace, but it's automatically placed for you and for the benefit of the users into the FDT Hub cloud storage, so that any FDT server or any FDT desktop that needs that FDT3 DTM to support a specific facility can automatically gain access to those DTMs. This is just a little bit more on the certification. So you generate your DTM, you run it through the FDT DTM inspector in your own facility just to make sure you've got everything ready for accreditation. You then negotiate a contract with one of the independent accredited FDT test sites. And once you pass all the criteria there, they pass it on to our FDT certification office, at which time you get a digital certificate signed by the FDT Group, and as well as being published in the FDT certified catalog on our website. So just to wrap up some of the business benefits from an FDT3 mobility perspective, we really provide an open and standardized way of integrating all the devices and networks within a facility. We support all the platforms that you could possibly do this on: mobile devices, tablets, desktops, different types of servers, and so on. We've built it to be secure from the ground up so that all these remote access points accessing a server are doing it over a very secure, robust connection that's been authenticated using industry standards. We can authorize independent mobile devices and users separately. So if you really want to ratchet down security in your environment, you can make sure that also only authorized mobile devices can even access the server before your users can log in. We support customized app development that benefits both the OT and IT side of the organization. Either part can develop apps either around the OPC UA interfaces that Smitha covered so well, or through our general web interfaces. So we really see this as the way to empower the new industrial workforce that's looking for modern, efficient tools that want to be able to do it wherever they are. And it's all built around a service-oriented architecture. And as you'll see many times in demonstrations and so on, it fully enables a cloud-based asset management capability if that's the direction your organization would like to go. So to wrap up, just be aware that when we conclude this session, you'll get an email pointing you to some handouts, and those include our FDT3 architecture brochure, the FDT3 white paper about developing innovative business models with FDT3, our new FDT3 mobility white paper that covers the mobility aspects of FDT3, and also a very nice piece on the specific FDT offerings that Utthunga has available for you as you further explore the FDT3 capabilities. So with that, we've got some questions and answers, and you can feel free to continue to ask your questions in the chat board. But Smith and I will start to address some of the questions. And I do not see them on my board, Katie, just so you know.
I can see it, Glenn. Yeah, maybe I can read out the question.
Go ahead.
Here. Yeah. Which profiles does the internal OPC UA server support? Maybe I'll answer that. With respect to OPC UA, it is a standard profile that is being supported. It is based on FDT OPC UA information model, which requires you can even call a method and everything. So it's basically a standard profile. Next question is, do the device DTMs define which information model is added for the device in the OPC UA server? To answer this question, it is not the device, because FDT wants to ensure that all the devices, whether it is whatever the communication protocol it supports or the device profile it is treated equally. So it is the FDT OPC information model that defines what information to be exposed. That to say it simply, whether you are connected to the sensor, temperature sensor, or you are connected to the actuator, both of them via FDT OPC information model, you will be able to receive the device identification information, and you'll be able to receive the online and offline configuration of these devices and process values, device health status, and many more. So this is what FDT OPC information model provides, but you are always free to extend this OPC information model in case if the FDT server can do it by expanding this. So, but this is a host specific behavior. But technically, device DTM will not have any hold on the information that is being exposed via FDT OPC information model. Next question we have is whether, okay, it's supposed to be FDT 3.0. FDT 3.0 will support IDTM. Maybe I request Glenn to answer this question.
Yeah, yes, it should support IDTMs. A question, then that's a specific brand name of a particular DTM, but you should consult with the individual vendors for those DTMs to understand what their migration plans are for those. I know a number of the companies are currently undergoing updates and enhancements to DTM, so I'd encourage you to talk with your individual vendors. But architecturally, everything's there to support those kinds of interpreter DTMs. In fact, if I could just add there, you will also see the FDT Group releasing later this year an IO-Link interpreter DTM, which allows any IO-Link device to work with the FDT standard without having to have a vendor-specific DTM for it, just as an example.
Yeah, thanks, Glenn. Another question we have is, any simulation or advanced testing of the field instruments through OPC is possible? In my opinion, this is out of today's webinar topic, but Glenn, do you want to answer this?
Yeah, it is a little outside. I would say that if the device can expose it through OPC UA, then yes, but I think I suspect there's more to this question than that simple of an answer. So maybe we could even try to answer this one offline, Smitha.
Yeah, sure. Yeah. Is there any COM DTM available based on OPC UA? Glenn, it would be good if you answer this.
I missed the beginning of that question, Smitha. What was that?
Is there an COM DTM available based on OPC UA?
No, because the OPC UA server is built into our server. We didn't have to issue, a specific COM DTM, as it were. We offer a native OPC UA interface. Now we are watching very carefully, obviously, what the OPC Foundation is doing with their new field protocol. And I think at that time, once that gets some more specifics built around it in terms of how that's going to work, then you would probably see a communications DTM for FLC.
Yeah, sure. So another question that we have is, do you envision many standalone apps being developed, or will mostly be likely developed by DCS supplier and the like? In my opinion, yes, we are anticipating more standalone applications that we mentioned in the case studies being developed in the near future. And it need not be only DCS supplier who will be developing this, but it could be any other app providers who are aware of developing this mobile applications can use these FDT interfaces to develop the simple app. So the focus is on the use cases and solving the problem than learning FDT technology or underlying technologies. So that is the simplicity that FDT wants to bring in here. Another question we have here is the major concern of corporation is the security. What is the strategy to change this behavior? Glenn?
Well, as we know, security is never, a thing that you can stand still on, no matter how secure you are at one point. It seems that the game keeps getting ratcheted up. So from our perspective, we have clearly described how we're using the TLS protocol for all of our external connection points. You can, in that protocol itself, enhance the encryption standards that you use. So it supports the idea of continually advancing with larger keys, new protocols, those kinds of things. So the TLS standard in and of itself gives us a fair amount of flexibility, but we are also looking at other ways of enhancing the security and confirming the security. So in the past, we've had independent audits of our standard, and we're currently investigating doing that again with our FDT3 standard.
Yeah, thanks, Glenn. Another question we have is, the question is if we talk to device via OPC instead of field bus. Yeah, this is the most debatable questions that we keep having it in most of the consortium, whether why the device itself can have this OPC in it instead of having this communication protocol. Technically, it is possible. We can have a OPC UA itself, information model itself as part of the devices, but there are already many millions of legacy devices that is being there which needed the support. And FDT technology is harmonizing these underlying these device networks and giving you the information model in a more harmonized way. If you have a device and OPC UA on top of it, then it will be like you have to connect to each single device, it is fine. But when you're talking about the entire plant network, then definitely FDT OPC UA information model is much more harmonized way, is what I can say.
Yeah, if I could just add to that, Smith, I think and maybe this is what generates that question, we've already seen that some of the protocol associations that we also work very closely with have issued their own OPC UA information model to support their particular network or protocol. And that's great. It really is a good move forward by those organizations. But if you're a user of multiple networks and protocols in your facility, you're now saddled with multiple information models to deal with. As Smith has said, I think the great advantage of the FDT standard in that environment is that we standardize all of those to a common information model. So that's critical to maintaining our posture that the end user, when working with the device, getting information, configuring it, whatever it might be, shouldn't be concerned about what network it's on, what node it's on, what adapter it's connected to, and all the things related to that. Same with the OPC UA information model. They shouldn't be concerned what the network is. They're after the information through the OPC connection. And that's what we do by offering a common harmonized information model for all of those networks.
Yeah, thanks, Glenn. We have almost exceeded 8 minutes, but however, I would like to take another last question. Rest of the questions, maybe we can answer it via email. So one last question is, what is the backward compatibility as we move from FDT 2 to 3, which are entirely on different platform?
Yeah, let me answer that one, Smith. So we specifically kept the FDT desktop environment as a means to have a mixed topology of different versions of the standard. So if you deploy the FDT desktop, you can have FDT 1.2, FDT 2, FDT 2.1, and FDT 3 DTMs in that mixed solution. So we see that as a great transition platform to move to a full FDT3 environment. When you do move to an FDT3 server, because the entire user interface is web-based and because it's also a platform independent solution, the older DTMs need to be upgraded to the FDT3 standard to be compatible on the server. So if you need mixed, use the desktop. If you're ready to go to a pure FDT3 environment, the server or desktop will do that for you.
Thank you, Glenn. I think maybe rest of the questions we can answer it via email. We have 10 minutes more.
Yeah, I think that's great, Smitha. We could sure do that.
Yeah. Thank you, everyone. Thank you for your great participation and very interesting questions. It's a pleasure to have you all here.
Yeah, and thank you from my side. Thanks, Smitha, for inviting me to the seminar today. It's great to see such a large turnout and look for the follow-up information after the seminar.
Yeah. Thank you, everyone. Take care and stay safe. Bye-bye.